Okay, so I'm gonna, this is the Pear deck for today, May the 3rd. The mayor of Greenville wants to analyze the lead levels of water in the entire city. Okay. The frequency table displays the data for the amount of level of drinking water, samples taken from sites all over Greenville. Okay, so what this means is the way you read it is there's 32 houses or sites that have lead from 0 to 5 parts per billion. There's 48 houses that have 5 to 10 less of water in water part per billion. 10 to 15 is 100. 15 to 20 is 47, and 20 to 25 is 23. Okay. Now all together, let's see, we have let's see, 100 and let me add it up. It's a good to have that number. We have 32 plus 48 plus 100 plus 47 plus 23. So there's 250 sites. So there's 250. So think about that. That would take like a long time to do like a dot plot. That's why we're not going to do a dot plot. So what we're going to do is we're going to do a histogram. Okay. So another way to display the quantity data is to create a histogram. A histogram is a graphical way to display quantitative data using vertical bars. The width of the bar in a histogram represents an interval of data and is often referred as the bin. The height of each bar indicates the frequency, which is the number of data values included in any given bin. Histograms are effective in displaying large amount of continuous data or data which can take any numerical value within the image. So that's what we're going to use a histogram. So construct a histogram to display the data in the table. So let's go ahead and so you want to do like an L. Let's see. Let's go by 10 right here. That we got 100, 90, 80, 70, 60, 50, 40, 0. Let's make this a little bit smaller. Oh, too small. Okay. And on the bottom, let's go ahead and we go from 0 to 5. So we're going to go 0, 5, 10, 15. From 0 to 5, there's 1 bar. Okay, and let's go ahead and draw it. We can do a rectangle. Let's see if we can do a rectangle. There you go. Cool. And then we'll do like different colors. Okay, so from 0 to 5, there's 32. So there's 20. There's 20, there's 30. So from 0 to 5. There's 32 right there. And then from 5 to 10, there's 48. Color. So right before 50. And then from 10 to 15, there's 100. And there's from 15 to 20, there's 47. There's 47. So 47 is going to be almost as close as the yellow one. And then from 20 to 25, there's 23. Let's change the color. And there's our histogram. See, do we need to label the parts? Let's do that. So go ahead and label the histogram. So label the histogram is like, what's the name of our histogram? So this is the amount of lead in drinking waters in selected sites in Greenville. So amount of lead drinking water of selected sites in Greenville. Okay. The bottom part, that will be amount of lead in parts per billion. And I'm gonna make another one, and then I'm just gonna put it on the side. This is the number of sites. Okay, let me. That was gonna let me do the where you can drag it. What did you do it? You might be able to do it on with using yours, where you drag it and move it to the side, so like sideways. Anyway, so there it is. Okay, so you can see most of the there's 100, so almost like 50% since they're 250. Probably more like 40%, I think 40, 100 divided by 250. Yeah, 40% would have are between 10 and 15. Yep. So there it is. So what conclusion you draw from the histogram about the amount of lead in the drinking water of Greenville? So conclusions would be that, like what I just said. So 40% of the sites have lead part per billion of 10 to 15. So let me see. 40% of the sites have lead a part per billion of 10 to 15. It doesn't sound like it's correct English. 40% of the sites have yeah, that's a little bit better. Okay, so 40% of the sites have 10 to 15% of lead in water. If we add the 100 plus the 100, go back so I can see the numbers. 100 plus 48 plus 32, that's 180. So we have 180 sites. There's 180 sites, or divided by 250, or 72% have less than 15 parts per billion of lead in water. So those are just two conclusions. We can also just focus on the 20 to 25. What percent would that be? So that's just like I said, it's just So Marcel created a histogram to display the same data and claims that no action has to be taken to reduce the level in Greenville drinking water. Is Marcel correct? Explain why or why not. Well, first of all, the important part right here is 15. Okay, and by going from 0 to 10 and from 10 to 20, you don't know how many of those are more than 15 or less than 15. So this histogram is not going to give you a very accurate number. So he's incorrect. So yeah, he's not correct because if you look at here, you can say, well, there's only like 20 that have more than 20. But again, I think that the 15 parts per billion is the one that the key. And with this, we can't tell like how many are less than 15 and how many of those are more than 15. Okay, does the water system management of Greenville needs to take action to reduce the amount of lead in the water? Explain your reason. Well, let's find out how many are actually more than 15. So 15 and up, there's 47 plus 23. So 47 plus 23 is equal to 70. So we have 70 sites that have greater than 15. Okay. So if what percent would that be? So 70 out of 250, or what percent would that be? Well, 70 divided by 250 times 100, 28%. 70 out of 250 or 28% of the sites have a PV of 15% or more. So action is required. Do you think a histogram is a good representation of the data? So a histogram, it's a good representation of the data if there's large numbers of data points given. Okay. So a histogram. And that's it. So that's it for today. Make sure you finish the slides. Also, work on the Khan Academy videos. Make sure you watch the videos and do the examples. I'll be here today after school to help out if you're from regular days, so from 12:40 all the way to 2:45 to 50. So if you need some help on the Khan Academy, come and see me. And I'll see you guys tomorrow. Thank you.